Let's take a look at Gaussian-Jordan elimination on a TI-82 calculator. Let's take a look at this problem. We got x plus y minus 2z is equal to 3, and 4x minus 2y plus z is equal to 9, and 5x minus y plus 3z is equal to 16. Excuse me. Now we looked at this on an earlier video. Remember our A matrix was the numbers off of our the left side here, off of variables. So I got 1, 1, negative 2. I got 4, negative 2, 1. And I got 5, negative 1, 3. And our B matrix will be the numbers on the right side. So we'll have 3, 9, and 16. And our answer is going to be the inverse of A times B. Well, let's do this quick way first. Then I'm going to show you how to use Gaussian-Jordan elimination. Okay, I'm going to enter in my matrix. I'll press my matrix button. Right arrow twice over to edit and do enter on A. Now it's asking us for the size, and it's rows by columns. So I do 3 rows, enter, and then 3 columns, enter. Type in each number, so press 1, enter, 1, enter, negative 2, 4, negative 2, 1, 5, negative 1, and 3. Let me double check all those. Okay, that looks good. So I exit out, do second mode. I go back to my matrix menu, right arrow twice over to edit, down arrow to B, press enter. And this is rows by columns. So 3 rows, 1 column. Now type my numbers. So I got 3, 9, 16. Okay, so I exit out, do second mode. Now go to my matrix menu, do enter on A. Then I'll push my X and negative 1 button, that's my inverse button. Times, go back in my matrix, down arrow to B, press enter, and enter again. So our answer, this is X, this is Y, and this is Z. Our answer is 3, 2, 1. Okay, Gaussian-Jordan elimination. I got 1, 1, negative 2, 3, 4, negative 2, 1, 9, 5, negative 1, 3, and 16. Our first step, we want to get a 1 in this position. We have a 1 in that position. So let's go down here to the next step. Okay. Now next thing we want to do is we want to get a 0 here, a 0 here. The process is you get a 1 in the diagonal. We're going to go down to the diagonal. You get a 1 there, and then you get zeros below it. So you think, what do you multiply times row 1 that you can then add to row 2 that get a 0 here? Well, if I multiply the 1 by negative 4 and add it to the 4, I get a 0. So we're going to take negative 4 times row 1, and we'll add that to row 2, and that's going to give us our new row 2. Now I multiply this 1 by negative 5 and then add it to this 5, that gives me a 0 there. So we're going to take negative 5 times row 1 plus row 3 is going to give us our new row 3. Well, let's go ahead and do that. And then I'll do it on the calculator. Okay. Negative 4 times 1 is negative 4 plus 4 is 0. Negative 4 times 1 is negative 4 plus negative 2 is negative 6. Negative 4 times negative 2 is 8 plus 1 is 9. Negative 4 times 3 is negative 12 plus 9 is negative 12 plus 9, negative 3. Okay. Negative 5 times 1 is negative 5 plus 5 is 0. Negative 5 times 1 is negative 5, and negative 1 is negative 6. Negative 5 times negative 2 is 10, plus 3 is 13. Negative 5 times 3 is negative 15, plus 16 is 1. Now I have trouble with these myself. I I make basic math errors. So the calculator will help us check to see whether we did it right or not. Okay. First thing I want to do is I want to input this matrix into A. So I'll go to Matrix, go over to Edit, do Enter on A. Rows by columns, 3 rows, 4 columns. So this would be a 3 enter, 4 enter. And you see part of it's off the screen. It doesn't matter, it'll scroll as we do this. So do 1 enter, 1 enter, -2 enter, 3 enter, 4 enter, -2 enter, 1 enter, 9 enter, 5 enter, -1 enter, 3 enter, 16 enter. Let me check all my numbers. 3, 9, 16, -2, 1, 3, -1, -2, -1, 1, 4, 5. Okay, now exit out, second mode. Now if I go to the matrix and I right arrow to math, if I scroll down, there's row swap. This is where you can add one row to another row. The 0 here is where you multiply a row by a number. And then this one here is where you multiply a row by a number, and then you add it to another row. So this is one we want. We want the very last one. And I'm going to have to play with this for a minute to make sure I got it right. Okay. I think I put the number in first. So in this case it would be -4, comma, and then my matrix name. So going to matrix, I do enter on A, comma, and I'm going to add this to row 2, row 1. I'm multiplying -4 times row 1, and then that's going to replace row 2. Okay, now let me double check this, see if it works. 0, -6, 9. Okay, I remember the syntax correctly. So let me write that down. Asterisk row plus. Okay, what we're multiplying it by, the -4. And then we tell it what matrix. We stored it in A. Then we tell it what row we're multiplying it by. We're multiplying it by row 1. And then we tell what row we're replacing. So 2. The last one here will always be the row we replaced. So then this one will be asterisk row plus, and we'll have -5, then A, and then we're multiplying it times row 1, and we're adding it to row 3. And that's going to give us our new row 3. Now when you do this over here, when I did this here, it didn't actually save it, which is kind of nice, because then if you don't remember the syntax exactly, you can just play with it and see. So if I do a second enter, bring up that previous entry, I can do a store now. If I remember where store's at. Probably looking right at it. There it is, store. And I want to store it back into A. So I'll do matrix, and I'll do enter on A, and then enter. Okay, and then that'll replace that matrix now. Okay, so now we want to do our next one. So I do matrix, right arrow to math, down arrow to the very bottom. Okay, we're going to take -5, working with matrix A, so I go into matrix, do enter on A. I'm doing commas between each one of these. Multiplying it times row 1, comma, and then we're adding it to row 3. And that'll give us our new row 3. Now let me do an enter first, just see how it looks. Okay, that looks good. So let me do a second enter, and then I'll do a store. We could have just done a store on the answer, by the way. Matrix, and then enter on A, enter again. Okay, so we're at the same place here. And I see I'm checking my basic math as I go along. Okay, got a 1 here, 0's below it. So now we're going to come to here. We want to get a 1 there. If I was doing this by hand, I would multiply -1/6 times row 2, and that'll give me my new row 2. Let's see how this goes. 1, 1, -2, 3. -1/6 times 0 is 0. -1/6 times -6 gives us a +1. -1/6 times 9 is -9/6, which is -3/2. -1/6 times -3 is a +3/6, or a +1/2. And I'll leave this one alone for the time being. Okay. Now on our calculator, I think we had a asterisk row. Let me check. So press my matrix, right arrow to math, down to the bottom. Okay, we have asterisk row. That's where we're multiplying a row by a number. See if I remember the syntax. Okay. I'll put negative 1, 6 first, and then I'll put A, and then I'll put which row, which is 2. Let's see if that works. Okay. And then negative 1 divided by 6, comma, and then go to the matrix menu, do enter on A, comma, and then row 2. I'll put a closing parentheses, though you don't need it. Ah, that looks promising. Now that we've done that, again, I can do a store, and then do matrix, and then do enter on A, enter again. Okay. So far, so good. Now we had decimals over there, but to change a matrix to fraction, all you have to do is math the enter, enter. Okay, working our way down. Got a 1 here, zeros below it. We got a 1 here, so we need to get zeros below it. So we can get a 0 there. Well, I'm gonna take this 1 by 6 and then add to negative 6, get a 0 here. So I'll take 6 times row 2, and I'll add that to row 3, and that'll give us our new row 3. Let's see, 1, 1, negative 2, 3, 0, 1, negative 3 halves, 1 half. Okay, 6 times 0 is 0 plus 0 is 0. 6 times 1 is 6 plus negative 6 is 0. 6 times negative 3 halves is negative 18 halves, which is negative 9 plus 13 is 4. 6 times 1 half is 3 plus 1 is 4. Okay, to do this on our calculator, we're going to do asterisk, row, plus, and then 6, and then working with matrix A, and we're going to multiply it times row 2, and we'll add it to row 3, replace row 3. So that's how we'll put it in. Okay, so I'm going to go to matrix, right arrow to math, down arrow, to the very bottom, enter, do 6, comma, A, so I go to matrix, do enter on A, comma, 2 for row 2, comma, 3 for row 3, and then close parentheses, enter. Okay, that looks good, so let's store it now. So do store, choose matrix, enter on A, enter. Well, working our way down. Next one is I'm working this diagonal. I want to get a 1 here. Well, I'm going to take 1/4 times row 3, and that's going to give us our new row 3. 1, 1, negative 2, 3, 0, 1, negative 3 halves, 1 half. 1/4 times 0 is 0. 1/4 times 0 is 0. 1/4 times 4 is 1. 1/4 times 4 is 1. To do this on the TI-82, we're going to do an asterisk row, and then 1/4. That's what we're multiplying it by, and we're working with A, and then comma, and then which row, which would be 3. Okay, so I'm going to do matrix, right arrow to math, down arrow. Okay, it's this one. So I'm going to do 1 divided by 4, comma, then matrix, and then enter on A, comma, 3, and then enter. Yeah, that looks good. Now I got to store that. I would recommend not storing this to begin with. Just do it and see what it looks like, and then you can press your store and do matrix, enter on A, enter again. Now at this point, this is now in REF form. This is row echelon form. For purposes of what we're doing, row echelon form means get a diagonal 1, zeros below it. Now at this point, we put our X, Y's, and Z's back in. So this is my X. I put my X's back in here, Y's in here, Z's in here, and this is my other side of the equals. So for my first row, I have X plus Y minus 2Z is equal to 3. For my second one, I'd have y minus 3/2 z is equal to 1/2. Then my last one, I'd have z is equal to 1. And you'd use backward substitution. You have z is equal to 1. You take that 1, put it back into z here. And this gives you y minus 3/2 equals 1/2. Take negative 3/2 over, and this becomes a positive 4/2 or 2. So you get y is equal to 2. So then you put 1 here, you put a 2 here, and you solve for x. I'm not going to show it, but that'd be backward substitution. We're going to do a full Gaussian-Jordan elimination, or REF. So now that we worked our way down, got diagonals, or got our ones in our diagonal and zeros below it, we're going to work our way back up. So I'm starting with this one down here, and now I'm going to go in reverse. I'm going to work at getting a 0 here and a 0 here. Okay. 0, 0, 1, 1, 0, 1, negative 3/2, 1/2, 1, 1, negative 2, 3. Okay, I'm going to multiply this 1 here by 3/2, and then add to this negative 3/2 to get a 0 here. So I'll take 3/2 times row 3, and I'll add that to row 2 to give us our new row 2. And down here I'll take this times 2, and then add it to the negative 2 to get a 0 there. So we'll take 2 times row 3, and add that to row 1 to give us our new row 1. Okay, now how that would look in terms of your calculator is we would do an asterisk row plus here, and 2 comma a comma the row we're multiplying it by, which is 3, and then the row we're adding it to, which is 1. And this one will be asterisk row plus, and number we're multiplying it by, which is 3/2. Matrix working with is a, and then multiplying it times row 3, and we're adding it to row 2. Okay. Let's see what we get. 0, 0, 1, 1. 3/2 times row 3, and then add to row 2. 3/2 times 0, 0 plus 0, 0. 3/2 times 0, 0 plus 1 is 1. 3/2 times 1 is 3/2 plus negative 3/2 is 0. 3/2 times 1 is 3/2 plus 1/2 is 4/2 or 2. Now 2 times row 3 plus row 1. 2 times 0 is 0 plus 1 is 1. 2 times 0 is 0 plus 1 is 1. 2 times 1 is 2 plus negative 2 is 0. And 2 times 1 is 2 plus 3 is 5. Let's see if the calculator bears out what I just said. Press matrix, right arrow to math, down arrow. And we want the last one. And then I'll do 2 comma matrix, enter on A, comma 3 comma 1. Okay, that looks right. So I'll do store, then matrix, enter on A, enter again. Okay, then we'll do our next one. So I'll do matrix, right arrow, down arrow, clear to the bottom, enter on that, and then 3/2, so 3 divided by 2, comma A, so I'll do matrix, enter on A, comma 3 comma 2, and press enter. And that looks promising, so I'll go ahead and push my store, and then do matrix, enter on A, enter again. Okay, one last step. We're of course we had a 1 here, but we got zeros above it, so we'll go back up to our diagonal. So I'm taking a look at this pivot point, and I want to get zeros above it, so I want to get a 0 here. So you think, what do I multiply times 1 that then can add to 1 to get a 0 here? Well, that'd be negative 1. So we're going to take negative 1 times row 2, and we'll add that to row 1, and that'll give us our new row 1. In terms of TI-82 notation, that's asterisk row plus, negative 1, comma A, comma 2, comma 1. 0, 0, 1, 1, 0, 1, 0, 2. Okay, negative 1 times row 2. Negative 1 times 0 is 0, plus 1 is 1. Negative 1 times 1 is negative 1, plus 1 is 0. Negative 1 times 0 is 0, plus 0 is 0. Negative 1 times 2 is negative 2 plus 5, which is 3. And let's do it on the calculator. Press matrix, right arrow over, down arrow. Choose the very last one. Choose negative 1, comma, matrix A. So I do matrix, enter on A, comma, 2, comma, 1. And press enter. And that looks good. So I'll do a store and do matrix, enter on A, enter again. Now our goal was to get a diagonal 1, 0, 0, where else. In this first 3 by 3, see how I have that? Diagonal 1, 0, 0, where else. This is RREF form, reduced row echelon form. Now the TI-82 does not have a RREF function, unfortunately. Once you get in that form, then the far right column is your answers, assuming it matches this exactly. Diagonal 1, 0, 0, where else. So this is X, this is Y, and this is Z. So our answer will be 3, 2, 1. Which, if we scroll clear to the top, you see that's what we got very easily just by using matrices like that. So my recommendation is, if there's no stipulation on how to do it the easy way, like I first showed you. And if you're required to show all the steps, you can use this to help double check your basic math. Now, it doesn't get around. You still have to understand what in the world you're doing. It just makes sure that you don't make any basic math errors. Now, that was finding using the RREF to solve a system of equations on a TI-82 calculator.